In this video, I will walk through the notes in the note sheet that's about using matrices to solve systems of equations. So we've worked with solving systems of equations in several ways so far. So if we have this system, 2x minus 3y equals negative 4, negative x plus 4y equals 7. It's two variables, x and y, and two equations. And so the inverse method would be able to set up a coefficient matrix and a variable matrix. And then you have your solution matrix. So the coefficients is literally just the coefficients of your x and y. And then you have your variable matrix, which is x and y vertically, and the solution matrix also vertically, negative 4, 7. So now, why that works is because as you're doing your matrix multiplication, you remember that you go across the row and then down the column. So this is a 2 by 2 matrix, and this is a 2 by 1 matrix. So since those values are the same, you're going to end up with a 2 by 1, which is exactly what this is, a 2 by 1. So as you do that multiplication, you do 2 times your x, which is 2x, and plus negative 3 times y. So negative 3 times y is a negative 3y. So you have those two products. And then for your next spot in the matrix, for the 2 by 1, you have negative 1 times x, which is negative x, and 4 times y, which is a positive 4y. So this would create our 2 by 1 matrix, and that's supposed to be equal to negative 4 and 7. So as you see that now we have a 2 by 1 and another 2 by 1. Now don't be deceived, this is just one row all the way across here, 2x plus a negative 3y. And so that's why you end up with your system as it stated in the beginning. These are two matrices which are the same dimensions, 2 by 1, 2 by 1 and 2 by 1, and in order for them to be equal to each other, the corresponding elements have to be the same. So that's how we know that 2x minus 3y equals negative 4, and negative x plus 4y equals 7. Now, you could solve this system using any sort of elimination method, right? So you could solve with elimination once you actually have that original system. Or you could use your inverse method. You have ax equals b, right? So the product of a times x equals b. All we would need to do is put an inverse of a on the left side, as we talked about in our previous videos. And you have the inverse of a on the left side of both sides of your equation. That is going to multiply out to be your identity matrix. So you have x is going to equal the inverse of a times b. Now that would be using the inverse method. So we've already talked about the inverse method in previous videos. So as you did that, you'll just have to go into your calculator and enter matrix A and enter matrix B, and then just type that in with your inverse button. You could also do all the work that we've discussed with the elimination many times before. This video also is going to talk about what's called the Rref method. So with that Rref method, as the notes state here, the notes state that we're going to create what's called an augmented matrix. So we're going to augment our coefficient matrix, which is still that 2, negative 3, negative 1, 4, with another column. I like to put a little vertical dotted line in there, negative 4, 7. So your original system is going to turn into an augmented matrix. You have your coefficients, 2, negative 3, negative 1, 4. It's going to be augmented with negative 4, 7. So this is your augmented matrix. And what we do now is we use the calculator to help us do what we call reduced, it's the technical term, reduced row echelon form. So we're going to use our calculator to get us to here, which is going to turn our matrix into 1, 0, 1 and 0, 1, 2. So still have that augmentation there. Well, this is our x column, this is our y column, and this is our solutions column. So that means that 1x plus 0y is equal to 1. Right, just how we set that up before. 0x plus 1y is equal to 2. So that means that x equals 1 and y equals 2. And doing that would be what's called the Rref method. Right, so that's three methods right there: elimination, inverse method and Rref method to be able to solve a system. How do you do the Rref on your calculator? Well, you have to enter this augmented matrix into your calculator. So if we do so, I already have that in here. That's a 2 by 3 now. And so as we look at that, that matrix is entered in there, 2, negative, 3, negative 4, negative 1, 4, 7. So now we're going to do some matrix math. And so you have to go over to the math column. Fastest way to get there to go up all the way to option B, which says Rref. That's exactly what we want. Reduced row echelon form. That's what the Rref stands for. So you hit enter, and we want to do that form of matrix A, which is that augmented matrix we have entered, and you see you get the same thing, 1, 0, 1, 0, 1, 2. So it's a very fast way. Your calculator can get the Rref for you, right? So it's a very fast way for you to solve a system of equations right from the very beginning. And so you'll see in the notes here, the next example, a practice problem, you have x, y, negative 3z, 0, 4x, negative 2yz equals negative 17, negative 2x minus 3y plus 7 equals negative 4. That's going to take a lot of work algebraically. You can use your calculator to get you there with the Rref. Right, so you want to convert this into an augmented matrix. 1, 1, negative 3 for the coefficients. 4, negative 2, 1, negative 2, negative 3, 7. And it's augmented by your solutions. This is what you'd enter into your calculator as a 3 by 4 matrix. You'd hit that Rref, and it would give you something in your reduced row echelon form where you see you have your identity matrix for the coefficients, and then you would get 3 different values for your x, y, and z. And you can take that the next level and talk about target M7, where we were talking about a parabola going through 3 points. You set up your standard form, you create your 3 equations, augmented matrix from there, calculator gives you the Rref, and boom, you got your A, your B, and your C to find your parabola that goes through those 3 points. So those 3 methods. Elimination, it's a great practice of all your algebra skills. Inverse method is talking about how we work with multiplication of matrices. And then the Rref is an advanced method where you use your augmented matrix. All great ways for you to solve a system.